I think I hear something.
It's a bit of a low hum, but yeah, I do
Okay.
think there's something going on there, at least on my end. If there's not, please put in the chat if there's any issues with anybody viewing anything or hearing anything.
Called War, Peace, and Quantum Mechanics.
Sofort der O-Ton, der andere dahinter, wegen links, rechts?
Nein. Can I gesture a little bit? Would you be able to get the gestures in?
No, I would see them, but...
Yeah. Okay. Not really. But I'd like to gesture a little.
Of course. Okay. If you come half a step in front, yeah, that's it. Okay, rolling.
James, why is it, do you have any explanation for it, that there are so many streets, places named after socialists, communists in the eastern part of Berlin?
Well, every regime wants to stamp its identity on the urban landscape, particularly one that's... My quantum journey began with a street fight in Berlin. I had come to the American Academy in Berlin to write a book about the making of Human Terrain, a documentary film about the U.S. military's effort to enlist American academics in the front lines of the counterinsurgency wars in Iraq and Afghanistan. It was not meant to be. Before I had even unpacked my bags, I was asked to write an opinion piece for the Berliner Zeitung. Seeking inspiration and some relief from the jet lag, I took a long ramble through the city. Every other street seemed to bear the name of a famous philosopher, general, or statesman, with more than a few named after American presidents. There was even one for the radical anarchist of the 1960s, Rudi Dutschke. By the end of my psychogeographic drift, my head had cleared. I had found a topic for the op-ed, the missing president. After all, the following week would be the 50th anniversary of President Eisenhower's farewell address.
Good evening, my fellow Americans.
The one where he famously warned against the unwarranted influence of a military-industrial complex, but also the danger that public policy could itself become the captive of a scientific technological elite.
My special thanks go to them for the opportunity of addressing you this evening.
I decided to ask why Berlin, the capital of the country that he had helped liberate in World War II, had no street named for Ike, no Eisenhower Strasse. Once dropped into the media pool, my small and insignificant op-ed began to spookily interact with new ways of information. Barely a month later, I found myself in the back of an unmarked van with a Deutsche Welle television crew, speeding around Berlin and providing on-camera commentary as we did drive-by shoots of streets bearing famous names.
And if you're specifically looking for monuments to Ronald Reagan...
We ended up at the Brandenburg Gate in front of the U.S. Embassy.
American officials feel that the year in which Reagan would have turned 100 is an apt time for the city to honor him.
We'd love to see any symbol of recognition of Ronald Reagan and his legacy for Berlin. I believe the early end of the Cold War had significant implications for Berlin and its people.
Nancy and Ronald Reagan during their famous visit to West Berlin back in 1987.
Mr. Gorbachev, open this gate. Mr. Gorbachev, tear down this wall.
2 years later, the wall indeed came down. Would the Americans be glad to see this prominent square renamed after Ronald Reagan?
The fact that neither Reagan or Eisenhower got a street name was lost in a bigger reveal, delivered years later in a speech by President Reagan's own Secretary of State, George Shultz.
I have a physicist friend at Stanford named Sid Drell,
who has given me the concept of quantum diplomacy. An axiom of quantum theory is that when you observe and measure some piece of a system, you inevitably disturb the whole system. So the process of observation itself is a cause of change.
Party for Germany, and behind us we have... That day in Berlin, in front of a camera with Marx and Engels behind me, George Shultz's message became the medium. War, peace, and quantum mechanics were entangled, and my quantum journey began. Use language, or use names.
Am Anfang bist du ein bisschen reingekommen, ne?
Ah, okay.
Ja,
I moved into the picture, so...
Okay.
Could you make it a little bit more brief?
Okay.
And talk about the division of the Western and the Eastern part of it?
In 1927, the world's leading scientists gathered in Brussels to make sense of 3 decades of new discoveries in physics and chemistry. 17 of the 29 attending were or would become Nobel Prize laureates, including Marie Curie, the only woman at Solvay, but also the only scientist to receive 2 Nobel Prizes. And also Max Planck was there, who coined the concept of quanta in 1900. German scientists who had been banned from earlier post-war conferences were welcomed back at Brussels. In a singular display of interwar solidarity, leading scientists from over a dozen countries were captured in an amateur movie, taken by the physicist Irving Langmuir using his own 16mm Bell & Howell camera. We see leaving the conference Niels Bohr and Erwin Schrödinger, Werner Heisenberg, Paul Dirac, Max Born, Louis de Broglie, Wolfgang Pauli, and of course, Albert Einstein. Madame Curie does a little dance. Paul Ehrenfest mugs for the camera. These remarkable scientists would intuit, debate, and eventually be proven right by experiments that the quanta in the form of photons and electrons could exist as both waves and particles until observed. The position and speed could not be simultaneously measured. They could correlate non-locally across vast distances. They had opposing spins and could not occupy the same space. And that a cat in a box could be both alive and dead at the same time. These principles of complementarity, uncertainty, the wave function, superposition, exclusion, and entanglement would become the foundation of a revolutionary new theory of physics, quantum mechanics. Quantum mechanics would rock many of the scientific as well as philosophical truths of the 20th century. The theory repudiated much of Newtonian physics at the subatomic level. It bent classical conceptions about space and time at the cosmological level. It cast into doubt assumptions about causality, prediction, and an observer-independent reality at the metaphysical level, eventually giving rise to new disruptive technologies. Quantum mechanics would change geopolitics forever. The 5th Solvay Conference on Physics was a high watermark of internationalist scientific cooperation. However, the amateur film ends with a premonition of a darker future that might lie ahead. Like many of the other principles enshrined in the Covenant of the League of Nations, scientific internationalism would not survive the rise of anti-Semitism, militarism, and totalitarianism. With Hitler's ascension to power in 1933, quantum mechanics became identified as a Jewish physics. Not even Werner Heisenberg, who would later head the Nazi Germany's atomic bomb program, would escape accusations of being a white Jew for his past affiliation with the ideas and creators of quantum mechanics. In 1939, the key Solvay scientists, many of them now refugees from European fascism, would gather again at Einstein's new home, the Institute for Advanced Study in Princeton. They had come to hash out their theoretical differences about quantum mechanics, but powerful forces were about to be unleashed within the atom as well as inside Europe. While at the Institute, the physicists produced a letter and an article that would help change the course of history. The letter from Albert Einstein and the Hungarian physicist Leo Szilard was sent to Franklin Roosevelt. They warned the president of a new source of incredible energy from the splitting of an atom that could well lead to the construction of extremely powerful new bombs. 1 month later, Niels Bohr and the Princeton physicist John Wheeler produced an article on the mechanism of nuclear fission. It was published September 1st, the same day Germany invaded Poland and the beginning of the Second World War. A political chain reaction followed: the Manhattan Project, Los Alamos, and the dropping of 2 atomic bombs on Japan. 7 years later, after the bomb helped end the Second World War and start a Cold War with the Soviet Union, Einstein voiced his regret for the inability of humankind to manage the powerful technology he and other physicists had brought to life. Without quantum mechanics, there would be no atomic bomb or nuclear revolution, microprocessor, or information revolution. In the first quantum revolution, thermonuclear weapons helped end a world war and dominate a bipolar order. In the second revolution, information technology helped network societies, hyperglobalize the economy, and, sadly, balkanize global politics. Now, a third revolution is stirring in quantum computing, communication, and artificial intelligence, with the potential to transform how wars are waged and peace is made. Instead of a letter or an article, we decided to make a film. The Solvay conferences became the model for international symposia that we would hold annually at Q Station, the former quarantine site of Sydney Harbor. We would travel to Copenhagen, Singapore, Ann Arbor, Silicon Valley, Shanghai, New Delhi, and other key sites to track the origins, evolution, and potential convergence of quantum science, technology, and geopolitics, all in search of answers to questions raised by a third quantum revolution. When will it happen? What will it mean? Who will benefit?
There were many of the scientists who were involved in the Manhattan Project who had second thoughts, and since almost first thoughts. The first thought Bohr had when he heard about the program was not really how to do it scientifically, it was to think about the political effects as the first reaction.
Why did Werner Heisenberg go to Copenhagen in September of 1941 in German-occupied Denmark at the height of Germany's expansion during World War II? Why did he go, and what did he and Bohr talk about?
People who actually started quantum mechanics also had a hard time understanding it and explaining it, and it is still considered one of the most exotic fields of all of science.
We speak somehow about the quantum revolution as if it has not already started to occur. The fact is, almost everything around us is powered by our mastery of the most basic phenomena in quantum mechanics.
We can actually test it. It's an invitation to take a philosophical question into the lab. And how often do you get to take philosophy into the lab?
Measuring devices are big objects, and big objects don't obey the laws of quantum mechanics, so there's something different. With the advent of the hope of building a quantum computer, we start to realize that bigness has nothing to do with that.
There are still at least 4 strong competing technologies to see which one will be the best technology for quantum computing.
A time is coming where we're going to be making use of those distinct and different aspects of the quantum world and using those different aspects for revolutionary, disruptive things.
As a scientist, fundamentally, the most rewarding thing is, can you control the quantum world? So it's really understanding nature at its fundamental level.
What I love about building a quantum computer is all these concepts become very natural for you.
So as a result of these Bell experiments, we have to accept that nature is not classical. We have to accept that our way of thinking about things is actually to some extent wrong.
I believe that life is kind of uniquely poised between the quantum and the classical world.
You can always figure out who we are,
where we are, where we're going, and what we should do. That, to me, is a classical Newtonian metaphysic, and the quantum world kind of it changes all that, blows it all up.
Consciousness, and by extension, human subjectivity, is a macroscopic quantum mechanical phenomenon. We're basically walking wave functions.
I think we're all quantum, so in that sense, I would say we could say that we're quantum computers, but I don't mean anything particularly exciting by that. So
I think the best possible uses of quantum computing are going to be applications of quantum artificial intelligence.
Right, the dream of control is the reason why we want artificial intelligence. And the problem there is a philosophical problem there. Because if we equate consciousness with intelligence, then it's by definition beyond control. So I think it's an impossible dream.
I'm sure people will find a way to use quantum computers in warfare. There is no doubt about it.
The more that we speed up our conflicts as nations using artificial intelligence, the more we reduce our decision space.
When you say quantum internet, I just think this is a much faster, more efficient way to gather information about people's habits.
How you put the dial of your society to say, well, things may go wrong, but if they do, then is that a problem for the collective, or is that a problem for the individual? That is a profoundly ethical moment.
If it is a race, it might be a race that all of humanity wins, but also about the rise of China, about how we've seen AI and quantum in China really take off for the last few years, and the challenges that poses to our security and to our economies.
When haven't we mobilized every kind of human effort to refine our techniques for how to destroy ourselves?
Instead of kind of conceptualizing development in this area as mirroring the space race or the arms race during the Cold War, but instead take this opportunity to use science and technology as a vehicle, a driver for international cooperation.
You know, the distance between we and God is a quantum computer.
This is the ultimate mystery to solve, you know, how the universe works.
Bohr may have had his own insight about this, that one of the ways to unlock the meaning of the quantum shift in terms of humanity's story, because the quantum shift is fundamentally a story happening on the human, that the only way in would be through poetry.
Hello, I am Alex Wendt, and I am a walking, talking quantum wave function. And guess what? So are you. I know this might sound weird, which is okay, because quantum theory is weird, but it's about to get weirder. Before we go there, what do we know about quantum so far? We know that energy comes in discontinuous packets of waves and particles called quanta. We know that this wave-particle duality makes it impossible to measure position and momentum simultaneously without changing both, giving rise to the uncertainty principle. In the quantum world, objects cannot be said to really exist prior to observation. We know that subatomic particles can become inextricably linked and, in a sense, communicate without any apparent causal connection, exhibiting what Einstein dismissively called spooky action at a distance, or entanglement. And we know that quantum computing, which is based on the superposition of qubits rather than the on-off microcircuitry of digital bits, is about to go operational, which will be a real game changer. One after the other, through mathematical models, laboratory experiments, and cosmic observations, the quantum theories, principles, and effects have proven right. I have a new proposition. What if quantum effects reach beyond the microscopic world of particles and waves and into the macroscopic world of big objects, like our bodies and brains, and in particular, into the realm of consciousness itself? What if all our desires, beliefs, and feelings, meaning consciousness and all its intentions, are actually macroscopic quantum mechanical phenomena? Human beings would be, not metaphorically or analogically, but actually be walking wave functions. And since the rules, norms, and institutions that govern our lives are also rooted in our minds, this would mean that not just my intentions, but yours as well, and indeed all of our shared intentions, including those of societies, would be quantum systems too. Mind-blowing, yes? Well, many scientists, and not just classically minded ones, might say no. They would say that whatever quantum weirdness is going on at the subatomic level quickly washes out at the macroscopic level. This is a process known as decoherence. Anything big, wet, warm, and squishy like the brain cannot, on this view, possibly have quantum properties. There's only one problem with this claim. No one really knows how the brain, let alone consciousness, really works. Dig into the science and history of the mind, and one finds layers of metaphors and technologies littering the road to progress. In the Middle Ages, the mind and body were composed of wet and dry, warm and cold humors, whose flow was controlled by sin and the stars, prayer and penance. In the Age of Reason, the body took on a Newtonian look. All levers and pulleys with a brain that ticked away like fine clockwork, except when broken. Come the telegraph and the telephone, the corporeal and the mental were all tied together like wires and plugs on an operator's switchboard.
Sorry, you have reached a number that has been disconnected.
With the transistor, microprocessor, and networks, the brain became a computer, and the mind a protoplasmic version of the internet. However, the mind-body problem persists, and it's not likely to be solved by gods, Houston, or Google. Maybe we have been looking in the wrong place for the solution to the problem. Let's start with the wet stuff, the brain. Quantum brain theory holds that the brain is capable of sustaining macroscopic quantum coherence. So we are not only walking wave functions, we are walking quantum computers. This by itself does not solve the mind-body problem, because it doesn't tell us why those quantum computers would be conscious. But if true, it would allow us to project all the quantum weirdness going on at the subatomic level up to the whole brain. That in turn motivates the second part of the theory, which proposes that consciousness is not just a property of human beings or other complex forms of matter, but goes all the way down to the structure of matter itself. In short, matter at the subatomic level is intrinsically minded. Perhaps consciousness is not a classical phenomenon at all, but a quantum one. Whether this theory will gain broad acceptance remains to be seen. And in my view, to follow the dictum of many physicists, it is just too elegant not to be true. So, are we quantum walking wave functions?
Over the past several years, Project Q has invited a singularly diverse group to Q Station, the former quarantine site of Sydney Harbor. Physicists and philosophers, computer and social scientists, artists and writers, lawyers, diplomats, and naval officers are quarantined for 3 days, where they are asked to step outside their disciplines, professions, and comfort zones, to explore the societal, geopolitical, and ethical implications of a quantum future. But then came the great interruptions. First, the horrific bushfires, then the pandemic. The emergency of climate change and the exponential spread of the coronavirus was a wake-up call for us and many others. As the Q station itself became endangered by smoke, fire, and virus, its history returned with a vengeance. Long before the quarantine station was established on the north head of Sydney Harbour in the early 1830s, the site was an important place of ceremonial and teaching practices, as well as burial grounds for the indigenous of the area, the Gadigal peoples of the Eora Nation. In the first pandemic recorded in Australia, at least 50% of the Gadigal population were wiped out by the European smallpox virus in 1789. The native burial grounds would be displaced by those who came later and died while in quarantine from influenza. The history of first encounters between strangers and strange diseases would be repeated many times in many places and serve as an important reminder that climate emergencies and pandemics are human tragedies in which everyone is at risk, but not equally so.
Side of the harbour. The Gadigal clan is one of 29 that makes up the Eora Nation.
Political, economic, racial, gendered, and other demographic factors mitigate as well as elevate risk, and fear factors divide as well as unite peoples around the world. At the most basic level of life and death, climate emergencies and pandemics are issues of human security. First characterized in the 1990s by the United Nations as a child who did not die, a disease that did not spread, a job that was not cut, an ethnic tension that did not explode in violence, a dissident who was not silenced. If the question of security is ultimately about what makes us safe, then the climate emergency and COVID pandemic threw into high relief the failure of political regimes to keep us safe. In too many instances, decisions were made, or more frequently not made, by regimes at the national as well as international level, often making matters much worse before making them better. And yet, if there was a light that showed up through the cracks, it came from science. Playing catch-up and not always getting it right, contested by partisan politics, science provided the knowledge and technology to slow, if not stop, climate change, and to slow, if not stop, the spread and to begin the cure for the COVID pandemic. The Project Q response was to mobilize the metaphysics, heuristics, and aesthetics of quantum mechanics to better comprehend and communicate how nothing so small as a photon of light or a strand of viral RNA could have such profound global effects. As Sydney went into a second COVID lockdown, we staged Q6 with a little help from Zoom as a non-localized super-positioned event, and using networked media, we traveled from Sydney to Q Station to a global audience. The quantum revolution that began at the Solvay conference in 1927 is far from over. Not many outside this remarkable circle fully understood just how radically quantum mechanics would change the world. One notable exception was William Bennett Monroe, who used his 1927 presidential address to alert the American Political Science Association. It has been said that no metaphysical implications are necessarily involved in the quantum theory or in the doctrine of relativity. But it is difficult to believe that this can be the case. A revolution so amazing in our ideas concerning the physical world must inevitably carry its echoes into other fields of human knowledge. New truths cannot be quarantined. Rather than an echo, a deafening silence followed. The silence cannot continue as we face new quantum breakthroughs that rival the creation of the atomic bomb and the nuclear age, the invention of the microprocessor and the information age. When new technologies of quantum computing, communication, and artificial intelligence emerge from university labs, big tech companies, and national security agencies.
Not just in Australia, but all around the world.
When we awake to Q-Day, the moment when all classically encrypted information is to be rendered visible by quantum computers and algorithms, what lessons then will we have learned from past quantum revolutions? We know from Albert Einstein's famous lament and Robert Oppenheimer's deep regret how the first quantum revolution changed everything except our ways of thinking. In the highest and possibly the last stage of the second quantum revolution, we seem unable to comprehend, let alone manage, the dangers of generative artificial intelligence. Now, as we face a third quantum revolution, we need to become fluent in what Armen Sarkisian, the former president of Armenia and a theoretical physicist, called quantum politics.
We are seeing a lot of uncertainty, unpredictability, and we have a complete discomfort like scientists 100 years ago when they couldn't explain classical events. So, welcome to the new world, welcome to the quantum world.
We need to revive the internationalist spirit of the Solvay Conference to break out of antagonistic rivalries and to free ourselves from the disciplinary silos that keep physicists and philosophers, politicians and entrepreneurs, humanists and artists from talking, learning, and working with each other. But we also need to recognize the opportunity as well as responsibility that comes with the singular convergence of quantum theory, science, and technology. Each of us, increasingly entangled, superpositioned, and facing conditions of radical uncertainty in a third quantum revolution, have the potential to create new realities with every measurement, every observation, every decision. In other words, and in one of many possible worlds, the future is ours to make.
All right. Kelly, are you still here? There you are. Okay. So this is kind of an open discussion. I just wanted to make one observation up front. And this is something that James and I have talked about in the past on a number of occasions. His project and the film, I think, does both of these things. There are two different kind of tracks in the project. One track is quantum artificial intelligence, quantum computing, quantum technology, right? And that's going to proceed and develop over the next few decades, presumably uninterruptedly and so on. And that will have all kinds of revolutionary implications for our ability to manipulate the world and everything else. But the quantum technology angle doesn't say anything about brains or people. So the quantum technology angle, many people who are in that kind of stream of research have no time for the idea of quantum consciousness or quantum brains or anything like that. That's all kind of crazy talk, right? So that's the other part of James's project, which is he does buy into this idea that consciousness and biology and everything else is quantum mechanical too. So he's got the kind of biological consciousness dimension and he's got the technological one. They're not clearly separated in the movie, even though you can kind of tell which is which when he's talking. But those are the two, and both of those, I would say that's a fair description of the field as a whole of quantum theory as it expands. It's expanding into the humanities and the social sciences on the one hand, and expanding into pure technology fields on the other, which have nothing to say at all about consciousness and so on. So that's just an initial distinction to draw. I'm happy to, or anybody, we can talk about whatever you want. It doesn't have to be just me. Or we can go home. So it's up to you. We've got 44 people here, so that's not bad actually for a. I can't believe James made that movie. He has no production, he has no experience. I mean, I don't know how he did it, but anyway. Joyce, there's something.
Okay.
Oh,
There is a question, but I'm going to have a question for the main actor in the movie. So Alex, from 9 years ago as a working wave function. So what do you think now? I mean, like you mentioned, even like in the book and in the movie, like there's a quotation directly from you. Is that because it's just too beautiful, or too elegant not to be true?
right.
What
That's
else?
my favorite line in the book.
Yeah. What else? What other evidence? I guess like
So what is your? I'm not sure I understand your question. Sorry.
my question is that after 9 years, what do you think about other evidence like beyond it's so beautiful, so elegant, has to have use outside of physics?
Well, I think one difference in the past 9 years is the accumulation of quantitative statistical work that shows, I think, without a doubt, as far as I can tell, that all these psychological anomalies are resolved in one fell swoop if you take a quantum formalism and use it on them. And to me, as I mentioned in my opening remarks, that's an unbelievably significant accomplishment intellectually in science. So I think 9 years ago, there was a lot of evidence already, but now there's much more, I think, that for whatever reason, maybe the brain is not really quantum, maybe it just mimics quantum effects or something, I don't know, but in any event, that seems to be pretty much, and I haven't seen any classical pushback. I mean, are there any classical social scientists who are attacking quantum cognition and quantum game theory? I don't think
always.
Well, they're complaining, but are they actually making critiques that stick and that there's some kind of a dialogue? I don't know. I haven't seen many classical critiques of quantum cognition.
But actually, it is interesting because it's through those kind of competitions. Actually, we are lucky in a very empirical-based, empirical computational comparison-based paradigm to establish this. Because whenever we publish a new, for example, or thank you for Pavel, show in great detail about two-slit experiment on Thursday. I can share one example. We inspired early, like the first experiment we tried, actually is trying to mimic something with human decision-making inspired by the two-slit experiment. So that's the first try, but once you publish a new data like that, the established cognitive modelers will come up with, of course, their own version of model, because you can always develop a kind of model account for the phenomena. So it's so I hope on Thursday I'll explain at least in my little field, like how we show the advantage. But we're lucky we are in a very empirical based, accumulative, very competitive ones. But still, there are a lot of challenges just because whenever you publish empirical data, and people will come with a new one, and then you have to show, for example, maybe empirical data without a parameter feeding. And also another very big challenge with human social science, since everyone probably interested in social science here, is that it's even much harder to do experiments or do empirical data with society or humans than particles or fountains or other physical objects.
Well, and on that point, can I just, I mean, just to add to that, I mean, being in a field like international relations, where the individuals are trivial, it's really about states and gigantic organizations like multinationals and so on. Getting data that's going to be useful at all is extremely difficult. And so you're really forced to kind of go back to public opinion data, which isn't really IR stuff anyway. So this is a real challenge. Empirically, I don't have a clue how one would test these things out in an IR context. In psychology, yes, because we've got tons and tons of data, but in IR, the data are really poor, and I don't think would be able to tell you anything at all.
I think it's Pavel.
Well, I just thought I mentioned that I think Acacio Barros and Patrick Suppes, they had this paper where they tried to show that you could actually have interference effects in the brain, which would be classical. So in a way, that would be like that the brain, if that would be a correct model, then you could say that the brain kind of acts quantum-like. So, but it's like interference as such is not quantum. We have that in the classic. We have that with water waves, and we can have that with at the classical macroscopic level. But I don't know how that whether that article, it's already probably 10 years ago, and whether that was sort of discussed, and whether that would be this plausible explanation. But it's just an example of people trying to give classical explanations to some of these things.
Well, that's interesting. And I think I may have seen this article a while ago. I'm not sure. But Patrick Suppes does sound familiar as a name, and I wouldn't have come across it any other way. So yeah, on the other hand, I'm surprised at how few articles there are like that. I mean, there's a ton of literature now on quantum cognition, quantum decision-making, game theory, decision theory, everything else. And I don't see a debate. My sense is the mainstream kind of ignores it, or maybe they dismiss it. And maybe they publish an occasional article that kind of really goes after something specific. My own sense, though, is there's not much, they're not paying much attention. I don't know.
Actually, it's established maybe as because since publication in more mainstream journals such as Psychology Review, Trends in Cognitive Science, those current directions of psychology, those kind of more mainstream, like we established this as mainstream. Actually, I would say it's established as one of the few main paradigms for decision modeling nowadays. So I guess like at least those common questions, I think typically people get at very early years. Now we don't get those anymore, but early years is extremely few, like the challenge is extremely hard. But I think, but still getting all the challenges all the time. Like for example, those data getting challenged by different kind of paradigms all the time. But it's the nature of like social scientific work, at least in those social and behavior sciences for some of those. So I guess like on the other flip side, I'm not critical of this. Of course, I'm like, I wish this direction to go really well. I always pick this on Alex just because I feel it's almost like a really great effort. Is maybe the function of doing such a highly interdisciplinary workshop and conference to call for the brilliant brains out there from everyone here, and to think about ways the data you encounter, like I challenging my student with more interest in big data, like what's the big data? challenges because we have been coding and because big data right now, a lot of big data are very coarse. And then really, we can explain the phenomena, but then competing very well with the classical models because both can do well. So what's the point? So I think it's like how people from different fields can contribute to finding the nice abnormality or challenges in the field and like in our international relations, the big data, whatever, the social science to do to push it forward.
I'm envious that in your field, quantum cognition has become an established tradition. That is not true in IR, just based on the reactions to my book and stuff like that. It's very contested, I guess would be kind of the polite way to put it.
But Alex, you have a movie.
The data are not there. We don't have the data in IR like you have in cognitive science. So
you have a movie though.
We do have a movie now.
Yeah, I think if I say a little follow-up, for me, what you see, I think the situation in quantum mechanics is interesting in the sense that we still have all those interpretations. So it actually means that we don't even understand non-relativistic quantum mechanics properly in a full sense. And one way to say what the situation is that, let's say there is the macroscopic world, which is familiar to that exists. But also then there is what we might call this quantum world, or there's this level of reality where where everybody agrees we need quantum mechanics. And you see, in a way, the disagreement in quantum mechanics is about the relation of these two. Because, for example, if you start from just quantum mechanics, the Schrödinger equation, from that you cannot deduce classical mechanics. What the coherence gives you, it gives you many macroscopic worlds. It just separates, like if the wave function gives you two possibilities, the decoherence will then entangle those two with the environment. But as a result, you would actually have two. This is why we have the many worlds interpretation. Decoherence does not kill the other parts that we observe. So this is in a way this was realized, like David Bohm writes beautiful about this. He wrote this textbook about quantum theory in 1951, which is still I find that still very interesting reading. And so in a way we have the situation that what he says there is that in a way quantum mechanics has to presuppose the macroscopic world. Because because what we need the macroscopic world for our meter readings. To any measurement we make, it ends with the measuring apparatus has to have a part of it that we can describe with classical physics. So I can say that it will spin up rather than spin down. But then you see, but I have to presuppose, I don't get that, my meter, I don't get the meter from quantum mechanics. So I have to kind of assume that. And then once I have my macroscopic device, then I can, if you like, actualize these quantum possibilities then I can get them. And of course, and you might ask, well, is that a satisfactory situation? Because the other side of the story is that to understand any macroscopic system, we also need this quantum theory of molecules. So I don't know if that's a paradoxical situation, but it's kind of weird. The relation of the macroscopic and this, if you like, quantum, it's a weird relation. And personally, I don't believe in the many worlds. Therefore, for me, I haven't, maybe the Bohm theory solves the measurement problem, then we have to look into that. But if I think about the brain, then I would say that in the brain, we have a lot of we are macroscopic, and in the brain, there's a lot of functioning at the macroscopic level where we can use classical physics. But then my assumption, it's a bit like what Alex said. Then I'm assuming that there's also the micro level. Of course there are, the brain in some sense consists of all the electrons and the little thingies. Maybe there's an area, domain in the brain where those quantum objects are doing some interesting behavior. Like you could have this coherence, maybe there's entanglement, a kind of quantum processing, which is then amplified to the macroscopic level. So when I'm talking, it could be like if I say that there is this quantum coherence in my brain, which has to do with part of my cognition, maybe my perception or intelligence, somehow this quantum coherent state within the brain is then amplified to the macroscopic level because my tongue is a macroscopic, the sound waves are classical, and then it goes into your classical apparatus, but maybe your understanding of what I'm saying takes place in this, if you like, in the quantum part of your brain. This is the scheme, this is the sort of the general picture. And of course, then, you know, a lot of people are trying to implement in its practice. I mean, of course, the most well-known is the work by Penrose and Hameroff, where they have a lot of people are doing simulations, there are people doing experiments, and so I'm still kind of hopeful. But I mean, there are mysteries, because even if you look at the Penrose model, I mean, he has to bring in this, he has the superposition there, and he has to bring in general relativity to bring the collapse gives rise to consciousness. I mean, it's a very interesting theory, but somehow it's not the easiest theory to digest. And the trouble again there is that there's no straightforward transition from the quantum world to the macroscopic world that everybody would agree about. And this is why we have all these different, even this different quantum consciousness model. And this is where still, suppose that physicists would agree about what is the correct interpretation of quantum mechanics, that might also limit all possible quantum consciousness theories that we have. Right now, it's a little bit the Wild West, you know, almost anybody can propose whatever they want because they can say, well, I'm using this interpretation. And you see, and we're still far away from the situation which we might one day have, that we actually, first of all, we feel we understand quantum mechanics. We have a story to tell about how the micro influences the macro, and we can connect that with the brain and consciousness. So I don't know, 50 years, 100 years, I don't know.
Just quickly, I wonder if advances in quantum social science and sort of changing our model of human beings might reverberate back on physicists and how they think about quantum phenomena in general, because they're not expecting the mind to turn out to be quantum mechanical. But if that could be established more rigorously, we might have a clue into the nature of quantum phenomena at a subatomic level. I don't know. It might support a panpsychist view, for example. But anyway, I don't want to talk too much here. So
absolutely. No, I think that is a good question. And you see, I mean, I say this, I also don't want to I easily talk too long, but I say shortly that, you see, in Bohm discussed these analogies between quantum mechanics and thought in his 1951 textbook, Quantum Theory. Mm-hmm. And one thing then he thinks that, you know, it's like just as in quantum mechanics, if you measure position, you disturb momentum and vice versa. So analogously, in introspection, if you ask somebody, what are you thinking about? You will disturb the train of their thought. So, you will disturb the momentum of their thought. So there are these analogies. And what Bohm in a way is arguing that, okay, if these analogies are correct, then, well, we are familiar with our thought processes, how they behave. And this familiarity with our thought processes will help us to understand if they're quantum mechanics, if the two are analogous. So that's a pretty wild idea. It's not just that we use quantum mechanics to understand the mind. Actually, the very fact that our thinking is quantum-like makes it easier for us to understand quantum mechanics. Mm-hmm. And that's a pretty interesting idea from the, epistemologically, or it's a bit like, I think, what Alex was similar to what you were saying, maybe, that somehow these models can go back and forth.
Well, and that's nice for social scientists, because usually we're at the bottom of the status heap in the sciences, and you're at the top of the heap, basically. And so if the social sciences actually end up contributing to physics, maybe that'll kind of change the status ordering. I just noticed, by the way, that there were a bunch of comments and questions in the chat section, which I haven't even read yet.
So
people should feel free to.
Yeah, Andrew's not here, but I posted 2 links that he mentioned earlier about the EEG applications based on quantum algorithms. So I got this information from him and posted there. So I guess those are kind of examples to show why this quantum can be useful. Some of those applications has an advantage over some existing ones. But sometimes I also want to mention, for example, what Pablo and Alex was mentioning, how doing quantum social science or human behaviors observables, human observables. For example, myself and some other people I work with, we don't know what's going on with the brain because we're neuroscientists and there are evidence from all the directions. And but at least the cognition, decision, behavior model doesn't rely on classical or quantum. So we don't have to wait for the answer to do our modeling or data, but can be more independent from that view about the brain. And by the way, also, I guess maybe slightly different from the movie we just watched. Actually, for most cognitive scientists, the brain is not a really computer, it's a metaphorical reference, and theory is not saying the brain is really classical computer or quantum computer. It's just a way to theorizing, using those language to theorize the process. We can predict the observables, kind of like observe the behavior, what we can observe. So, but then this goes back to all the good questions I think talked earlier in the day about like, what's measurement, what's information, what is measurement, and so on. But I guess going back, I want to mention that even for kind of cognitive science is that it's extremely hard because cognitive science has a lot of people, scholars have a physics background. Actually, it's those people had the most resistance from the beginning about those kind of approach, because typically our field is very divided by our disciplines. Everybody should just only care about questions in the different disciplines. So I guess, for example, one concept like one of the key ones was mentioned in the chat is that compatible, incompatible observables. Actually, from my collaboration experience, our observation is that actually this compatibility is very different, actually much more interesting in human behavior than in particles, like maybe in physics, because it can be changeable, can from compatible observables become incompatible and so on, which is the key concept in quantum physics. Yeah, I guess what I was mentioning is that I personally believe there should be feedback into the physics field, but I think it has been extremely challenging. Even some of the physicists, favorite one like I think Richard Feynman said, like social science are pseudoscience.
Yes.
Yeah, those kind of things. Yeah, those are commonly.
So Jakub has his hand up. How did you raise your hand? I don't even see any hand things at the bottom here.
It's under the React button, I believe, but it's covered.
Okay.
I have comments to this. I think if we take what Chris Fields was introducing today seriously, I think there is this back and forth between natural and social sciences. And I think actually, Alex, it goes back to your comment or question, what is the added value of quantum social science? Because if social scientists, probably the critical social science is doing this stuff for some time, there are genuine insight, and if the two levels of theorizing are analogical, then there may be inspiration the other way, right? So if what Chris is suggesting that we basically see the same problem on all levels, then we can expect mutual inspiration here. But as you said, there is some hierarchy of sciences. so physicists are probably not that interested in hearing such ideas. But I wanted to Joyce actually inspired me to ask, since the book is out 9 years now, I wonder, there was lots of reactions, either public but I also believe some private, and I do have some conversation with different scholars, and I wonder, because for me the book is because it makes several quite bold claims. And I wonder whether there is a specific like point which is criticized, or whether, you know, that there's like because I could see at least like 5 different ideas that could be like suspicious to someone, that someone can, including panpsychism, including scaling it up to the society level, from the individual level, and so on. I wonder whether you could possibly clarify where is the main criticism of what you did 9 years ago.
I don't think there is any common thread in the criticism, except that we don't need this. That's really the universal reaction from positivists on the one hand. Well, they don't really react because they don't even notice what's happening. They don't see this at all. On the critical theory side, it's the we don't need this reaction. We've already got all this stuff covered. And there's a suspicion of physics and a suspicion of social physics in particular, I think, that's underlying that. So a lot of the critiques that I've read of the book really aren't very specific about real problems, unless it's to kind of echo standard problems like, well, there's the decoherence problem. Well, yeah, I already know that, so that isn't really anything new. So no, I've been rather unsatisfied with the quality of the critiques, really. They're kind of almost ideological critiques. It's almost as if I triggered some people somehow with these kinds of arguments. And so, but in the long run, it's obvious that this view is true. It's my view. And so it's just a matter of time. It may take more decades than I thought it would take, but I mean, what's the alternative? It's not as if classical social science is going to get way better. It's going to be as bad as it always was. So,
yeah, I would, if I may, I would take an example from Alex's book, which I find interesting. It's when you discuss this question of perception. And you in that chapter, and you start out discussing sort of direct versus indirect perception. And see, I think the thing is that there's still no agreement of about perception. It's still like at one level, of course, we don't, you know, we have no explanation why we perceive anything at all consciously, because we, you know, if we haven't solved the hard problem of consciousness. So, you know, perception is a fact, but then why are we conscious of it? I mean, they're all blind sight, and all, you know, it seems that information processing could take place, and some sort of action in principle could take place without consciousness, so we could be zombies. But the other question is, of course, that you see, for me at least, if I'm walking and looking at the forest, I feel this immediacy in the perception. And of course, if I go and listen to people like Anil Seth, they will. And a lot of people now believe, well, we're just hallucinating. So the brain, brain is producing this. It could be predictive processing or whatnot, the model, and so it's such a hallucination. It's an illusion that I'm seeing the real world. But I'm just within my models, which happen to correspond. And of course, there's a lot of evidence for that kind of view. So I'm not saying that we can do a black and white thing here, but I also think that. What I liked about Alex, he discussed his various fairly exotic proposals about perception, and then Alex suggests that it could be that through this quantum non-locality, which we find with light, it's almost as we are touching the objects that we are perceiving. And phenomenologically, that is exactly the way it feels like, at least. And so and you see light is something that everybody agrees is there in perception. Well, light, we understand quantum mechanically. I mean, there are, you know, entanglement seems very natural. So that's definitely an area which I'm thinking of trying to explore a little bit more and try to talk with some physicists, that if we could construct this new model of perception. And the other thing is the application of holography in neuroscience. And I was actually I was in Italy 2 weeks ago. There was a consciousness meeting, and there was this guy, I think, was it Cavalcani? There's a physicist, Jack Tuszynski. He has worked with Hameroff, but he also worked with a lot of people in Torino. And they are now they just published this year papers on this, how the principle of these models could be holographic principles. And of course, one idea there is that we could be there are projective holograms, that we could be literally projecting a holograph out there, which would act as a sort of, it's called phase conjugate resonant imaging, or or phase conjugate mirrors. So that when see an object out there, is because it's a kind of a quantum mirror which projects the visual object. We still need to explain the hard problem: why is there consciousness of it? But I think the way Alex is open up this, I actually gave kind of a tutorial on that in Helsinki University, Aalto University once, just really reporting pretty much what you were saying in the book. But I think that is an absolutely fascinating discussion. And I think people in this perceptual cognitive neuroscience, they're really stuck with they don't realize that there are alternatives. And that's, I think, what Alex has shown in the book.
Oh, good. Well, I'm glad to hear that. Actually, we have a hand up from Kate Barton.
Yeah, hi. I just wanted to add something that I think might be useful for people when they think about perception and why the problem of perception is so persistent. So when I was finishing my master's thesis this past spring, I sort of came into the quantum stuff through a back door. I was studying great power status and Russia's pursuit of status in the war in Ukraine, because status seemed extremely mysterious to me, because they've pretty much allowed for it to be completely separate from any material predictor or variables, and are now just trying to explain it as if it were material, with presenting it as it is, which is completely immaterial. And that was really confusing to me. And then I reread Alex's book, and I realized that if something is completely immaterial and only language-based, then it might just need a completely new perception through the quantum framework. So I was trying to figure out the perception problem by thinking about how there might be something at a deeper level that is reaching a mysterious goal, and then how perception is not in itself a process to be explained, but maybe a method to get at a deeper truth. So if I was thinking about applying that to my question towards great power status, I was thinking about how things can seem irrational, even decisions about huge conflicts can seem irrational, but we try to explain them just through states trying to gain more power. And then we try to explain whatever that means, whatever power means. But if we thought about that just kind of playing with our quantum vocabulary and letting ourselves theorize without wondering too much about what it'll mean for measurement later, I would replace power with the concept of superpositions, and think about if on the quantum level, what does it mean to have many possibilities, many superpositions, rather than a determined state. And if it were true, if we presuppose that the quantum methods were at work at that level, how would that change how we explain and the vocabulary that we would use? And just basically rethinking that whole theory. And then from there, you start with a hypothesis that you can start figuring out how to theoretically test. But I worry that we get caught up in these questions of how can we measure it, and how can we prove it, and how can we, say something to all the critics, but we don't really want to allow for the fact that it might need so much more exposure first. And like anything, the science will catch up. Mm-hmm. But those are the sorts of things that I would pressure people to open up to new ways of thinking. Because that's how I got here.
Okay, thank you. Well, thank you. I take it that's a comment more than a question, but there's a lot in that comment. Does anybody want to comment on Kate's comment or introduce anything else on the other themes here? Zrinka. Well, actually, Prince. Well, let's go to Zrinka and then Prince. Okay.
I think Michael was faster than me.
Oh, Michael, do you want to go first?
It's fine. I just wanted to add to the previous comment that I agree that sometimes it's maybe helpful to think of the best possible outcome. Say we can of an experiment. Say we can prove that entanglement makes sense in quantum social science or in a social system. What are the implications? How would we act? And just do it instead of waiting. Are doing, and then we will get something out, but that's not what we actually intend. We want to use the idea of entanglement to look differently about society. And then what if we just do it and think about the implications it would be, like more in terms of morality, in terms of sustainability, just do it. Whether there will be proof of entanglement or not, does it really matter? So I think this is what I heard from the previous comment.
Yeah, it's sounds good. Just do it, and then okay, when you start to do it, then everybody say, well, what are you talking about? What a strange stuff is that? Well, I would like to mention, well, it's very inspiring as ever, and especially what you've said, Alex, about that elegant approach, and in that moment, both in the film as well as in the conversation, I couldn't avoid not to feel and think about the ambivalency in the whole story. When I say story, I mean dealing with a quantum approach in science, in social science, in trying to implement it in education, etc. And on the other side, knowing that there is a huge technology, and technology was mentioned many times today, banking and whatever kind, or quantum computing is the obvious one, and there are a lot of non-obvious ways of using technologies. That's military one. That's also a research there. So my impression is, and especially now dealing with AI, almost, I mean, every day, is that we are kind of far away from where the real field is or not the real field, but the field where the harvesting of quantum idea is happening maximally is somewhere in the AI, in the military complex, industrial complex, etc. It's not in the science. And that makes me feel very uncomfortable because then, you know, all of a sudden there is a paper about governments, UK government working on weapons, AI and quantum and whatever. And then I wonder how, in God's name, how am I going to be able to explain anything to anybody in education frame about quantum and about necessity to think in different options, not only in that general classical one, but to broaden it a little bit. It seems a little bit, not a little bit, it seems very ambivalent at the moment, and the gap between that what we can do in science and what is going on somewhere else in that industry and technology is bigger and bigger. This is one complex thematically or content. And another one is, and it has been mentioned in the movie, is the convergence. And the convergence, what I've seen until today is the convergence between natural sciences, neurobiology, biological physics, or quantum this and quantum chemistry, etc., etc. And that work of yours, Alex, it's just unbelievably huge. And I wonder, and there are so many, there is a potential for sharing knowledge, etc. But there is, from my perspective as coming from humanities, there is nothing as necessary as the convergence of all symbolic forms, and to see what kind of benefit there is from the knowledge and ways of knowing and areas of knowledge we can come to. But on the other hand, in the academia, it's just difficult. And I wonder how other people deal with that. Probably most of you are not forced to deal with that, but yeah, I'm kind of coming from humanities, am forced to kind of constantly convince somebody from physics that if I write a paper on something that it makes sense not only for me but for anybody else. So these two things are kind of from that problematic side, and I wonder how do you deal with that, and how do you especially because coming from philosophy, the convergence of all different symbolic forms, it's a normal thing, it's a necessity, and this is how evolution is happening, is going on. This is how we evolve. But the structure of natural sciences, it's just we are the evolution, and everything else is just subdued, kind of below that. So this is both a comment and a question, how to deal with that, and in general, how do you deal with that inconsistency in research, and that the whole money is in LLM systems and AI and quantum AI and quantum computing, and how do you finance your research? This is also a question, especially for younger people. So thank you.
Can I just briefly comment? Is that okay?
Yes, please.
On the military thing, as an IR person, maybe I'm just jaded, but I just take it for granted that any new technology will go to the military first. So that's just the way the world is right now, and I don't think there's anything that can be done about that. It does worry me. On the other hand, the H-bomb and the atomic bomb, they were instruments of destruction, but they also helped keep the peace in the Cold War, arguably. At least people say that they did. So there could be different kinds of effects. But your point about the physicists, though, physicists being very skeptical of humanities people or social scientists doing physics, that's certainly been my experience. I've encountered plenty of physicists who think this is total nonsense and whatever. But one thing that's really impressed me both when I wrote my book and then ever since is how open-minded physicists are compared to a lot of disciplines. Compared to my own discipline of IR, everyone is certain that their view is the correct view, and everyone has a different view. And there's no sense at all of humility, whereas in quantum theory, I think the collective of all physicists know that they don't know what's going on. That's sort of a starting point of the conversation. And so that leads to more openness, more humility, and a willingness of physicists to come to a quantum social science boot camp. After all, 4 years in a row, we've been able to recruit physicists to come and talk to us, and they didn't think it was crazy. Now, of course, the ones who think it is crazy turned us down. So it's not as if, all physicists are open to this, but I've been pleasantly surprised. My brother's a physicist, so I was kind of predisposed, but I've been pleasantly surprised at how willing physicists are to talk about really weird ideas. And so maybe there's more hope there than one might think. So, but I'll stop there. Now, Prince, you had your hand up a little while ago. Do you want to say anything now, or is it out of?
I think it's partially connected to the way the social science field versus physics, and specifically now, we're doing quantum-like stuff, or we're trying to figure out which of us are quantum realist, or simply using quantum-like approaches. And I don't know why, we have this sense of inferiority complex in a sense versus the physics, in which, we have to justify the actual physics, the quantum physics, before we even attempt to see whether these concepts can be applied to a lot of things that we already have in the social sciences. When physics do the shut up and calculate, they pick an approach and see what function, and they work the method. I feel like we do a lot of, I have to justify the existence of what I do versus, hey, we've noticed these anomalies are explainable using these formalisms. We're going to see if there's anything there, versus beginning with your handout and going, we're not sure it's right, but we're picking, the topics from this field. We think this and that, instead of going, this is observables. It kind of maps out on these formalisms. Let's apply it to pretty much everything here and see what takes and what doesn't. I feel like that they're could be a lot of space and a lot of like discovery there. Even if in 50 years we find out that a brain is not, you know, a walking quantum computer, if what works, it works in a sense. So I feel like that should be a thing that we do. I feel like the more secure we are in our approach and the results we produce, and unless we feel like we're constantly on the defensive, justifying even using the approach, the better it is for people outside to believe us, because we don't start off as, well, we're not sure. We start off as like, yeah, these are the things we're doing. These are the results. Now let's discuss. I feel like that would be a better approach overall.
That'd be a more pragmatist kind of approach in a way that you're advocating. And no, I totally agree that just do it. But it does, especially if you're a young scholar, if you don't have tenure and you're getting a lot of resistance, that's professionally obviously risky and difficult. And so there are kind of real world constraints in a sense on how far out people can go. I mean, I wouldn't have written my book if I weren't already a full professor, for example. It would have been kind of risky to do that. So, but anyway, Joyce.
Yes, I just want to follow up with a few comments from my own experience. First is that it's with the military, it's actually with application of the military, actually it's not that terrible. Actually, especially like in this country, yeah, a lot of research fundings are from the Department of Defense, and has a lot, you know, they have classified and now classified. And now classified is a major funding for a lot of collaboration with the academia as well. And my own research in quantum cognition decision actually has been funded over the past 15 years by Air Force Research, and my prior PhD student now is a lead scientist there as a permanently work there as a lead scientist. So I don't feel like there is a lot of secrecy in that in that kind of aspect. But so this also suggests something, I guess, as a person survived those kind of maybe, yeah, like for example, I guess I wouldn't let my student do something I have done at the early career of myself. But like I feel like for example, in academic, in my field, right, you publish in the mainstream journals, be able to get in large federal funding is important. So just have to work along those lines. And funding the most important, have your great ideas compile with the kind of paradigm, possibly being fundable, possibly being able to publish in the mainstream journals. Unfortunately, that's the challenge. Because if looking at the history of science, evolution of science and technology, actually, for any new ideas, it's even more challenging, right? Like the criteria to say some theory is more useful needs to be really, you have to work really harder to show it has an advantage. Whatever your field requires to show, what's the advantage? So I guess, anyway, in the end, I feel like my own experience, actually, we are challenged more by established theories. That's I guess it's natural and understandable, because why people needs to learn something different. So anyway, that's just so when we need to like follow up a few of you have been mentioning, just go to work, find the paradise that's could prove and test your theory, or falsify your theory. Actually, to be if you hold the idea about theories to be falsifiable, and so on, yeah.
And actually, that relates to a comment that was implicit in some of my comments earlier, is that there are lots of low-hanging fruit. There's lots of articles to be written. My favorite example in the Bootcamp discussions when we were putting things together is nuclear deterrence theory. It's a game theoretic framework. It's very classical. It's obviously had a huge impact on the world. What if you quantize deterrence theory? Do you end up with a different perspective on the use of nuclear weapons and all that kind of stuff? And that's an article right there that could get published in a mainstream journal potentially. But that is the challenge, I think, that Joyce has identified, is finding things that can be published in a venue like that. And so we have another Heather. Heather wants to chime in here.
Yeah, Yeah, I wanted to add, in the Quantum Bootcamp working group, I wish he was here today. Kazuma Matoba has actually cited you, Alex. He did this wonderful article that he had shared with us on measuring collective trauma using a quantum social science approach.
Oh, I've seen that article.
Yeah, and it's really good. And I should have tagged it when we were talking about FIRCA, and measuring trauma and sort of these ripple effects. But through the course of this discussion, I always go back to this issue of my biggest concern with AI, apart from it being an obvious force multiplier, is it really is an adoption problem. And so if we don't look through, like even in Kazuma's article, he was looking at entanglement in historical perpetrators. If we don't even understand these, they're not even our past. It really is the present, and it's impacting us today in the IR space. And then we're churning out these increasingly powerful technologies, and we don't even understand our own actions with a critical eye. I just think, like you were saying on the deterrent issue, this is really what I think quantum social science can, I don't even want to say nuance perspective, because it's far more powerful than that. It's a necessary and critical perspective in that space, in that voice. So yeah, I think Kazuma's article is definitely worth revisiting for anyone wanting to look at it. It's not heady on the quantitative side.
You'll have to definitely mention that to Firka when she's here on Wednesday, I guess.
Yeah.
Yeah, Karin's an old classmate of mine, actually. She went to Minnesota just like I did. So, other thoughts, comments? I'm happy to wrap it up. I'm tired, but if you guys want to talk a bit more, I'm happy to hang in there.
There was one comment in the chat from Mark Wagner, perhaps interesting, about LLMs and active interference, free energy principle, etc. Have you seen that?
I see it now. Can you guys all see it? Regarding quantum social science and multidimensional model of minds and how this relates to AI models beyond LLMs like active inference based on the free energy principle. Both involve fundamentally quantum mechanics, field theory, and quantum information. I'd love some Bohmian dialogue on any of the fields related to quantum social science.
Can I comment a little on the Bohmian dialogue? Are you familiar with the Bohmian dialogue?
The book, I'm familiar with the book that he had with Krishnamurti, is that right?
No, there's another one that's called On Dialogue, because
I haven't seen that.
It's interesting because in a way, I mean, of course, with Krishnamurti, there were dialogues, but I think Bohm also felt that, well, there were some certain kind of dialogues, but perhaps maybe there the thing was still more trying to understand what Krishnamurti was saying, and perhaps Krishnamurti wasn't equally interested in what anybody else had to say. So maybe there was still a bit of a one-way direction in those. But this is something I think this would be actually very interesting as an application of to social science, because you see, in a way, the Bohmian dialogue idea is very simple. The challenge there is to be able to listen and try to understand what it means, what people say, rather than judge whether they are correct or incorrect. And it's kind of a Hegelian thing. If everybody would be able to do that, let's say we would have a Bohmian dialogue here and 20 people say something, we would actually be able to understand the meaning and suspend our immediate reactions. There would be this huge common pool of information. And I guess he had sort of a bit of a Hegelian idea that some sort of something new could come out of that. And this is definitely there in some of his articles on this active information quantum mechanics. He talks in the same article about this dialogue, and you can clearly see how it all, there's an analogy in the way you have a coherent quantum state guiding particles, and in a group, in the dialogue, something like a common pool of information could arise if people were able to listen to each other. So that's definitely worth looking into. I can maybe even send, I have some old articles, because I was interacting at BOEM at the time when he was doing this, and I participated in many of these experiments with him. And there are actually quite a few people who around the world who are pursuing this one way or the other. The MIT had a dialogue project, but there are many other groups, and that could actually be something where it would be an additional example of the way also quantum ideas could be useful for social sciences, or in this case a very practical communication, because Bohm would be the first to admit that his ideas about communication were influenced by his holistic framework, which quantum mechanics inspired. So I can send you some of the articles about that. But it's very nice the way somebody is mentioning it. The fact that somebody here is mentioning it is evidence that there is some people know about the Bohmian dialogue, and I was happy to see that there.
Great. Okay.
I would love to have. I'm actually working in field of cybernetics since the 70s, late 70s, and my definition of cybernetics is to design systems in harmony with how nature works, even at the quantum information level. And in building AI systems that are based on not just transformer models, but are based on like active inference, like I mentioned, something that is more in harmony with how nature works at all dimensions. And that informed my theory of mind, which I also apply to AI development, which is, and I posted something that explains really, I think, very well. I posted a chart in the chat about a spectrum of consciousness, where, like Max Planck, believing consciousness is fundamental, that matter is derivative of consciousness, consciousness exists through different layers of mind. Like the subconscious mind is, it gets recorded in the body because it's too much information too fast in several cases. So the body, since you didn't process it, the body records it to process later. That produces a field, which I think quantum field physics or theory really exemplifies, the field that's generated by every form. Think about that, kind of that toroidal field that's part of every form, from the smallest to the largest. Two superclusters of galaxies form the same toroidal field. That, to me, contains the quantum information of that form, which gets varied in interaction and at different scales. Another part of field theory is the scalar energy, which Einstein believed, I think is quoted as saying, it comes from outside the universe. It also measures amplitude, but I think it also measures qualities of the field. And these fields were multi-field models. It's really interesting going into the real deep nature of the biology. I'm going to get off on too many other tracks. I just wanted to draw attention to the spectrum of consciousness to show the subconscious fields are labeled on the left 3 columns of both sides of the page. And then there's a, that's called the shadow, which is the content of the subconscious mind, which puts a filter on our interpretation of experience and our expression through the same field. This level of mind is very useful for looking at the dynamics of social regards. Like instead of hierarchies, there was a image, I think it was in Chris's talk, that showed the multidimensional aspect of the Markov blanket, right? Well, which Markov blanket? Are we looking through the subconscious Markov blanket? Are we looking through the conscious Markov blanket, which extends beyond the subconscious field? There's even a superconscious field where we can understand, like this image behind me, a bunch of stars communicating via X-ray. Those are X-ray links between stars. Well, what are they saying? Beautiful well, there's a project in AI called the Earth Species Project, which is using language models and inference models of other types to decode what every species is saying. That can extend to the stars. This leap in understanding is going to be have a real effect quantum socially. It gets easier as the mind is less filtered. I mean, consciousness is less filtered by mind. It just keeps getting easier. There's less interference. There's less resistance to flow. That's why I like the free energy principle also. It describes the flow state solution, not the win-lose solution, the win-win-win solutions. Anyway, and synergetic solutions, which Bucky would be happy about. Anyway, I'd love to talk with any of you, and I'm really glad to have found this group. I've talked to Karen O'Brien a few times, and I just love Karen. And I even talked about the gene keys with her, which is where that spectrum of consciousness comes from. But there's such potential in group meditations, global meditations on shifting quantum social science. If we consider a definition of reality as based on agreement of experience, the most shared interpretation of experience. When we look at imagination, imagination, well, my father used to say, what was that limit on imagination again? I keep forgetting. And yet every time we use imagination, we create an experience. Now it's a reality to us. It's a personal agreement that we just had an experience. We even know we had an experience, which is wonderful to see. But when we have a collective imagination, like this group is a great example of collective imagination finding agreement closer and closer to truth. There's a little Bohmian dialogue right in this group. We're not being critical of each other. We're not judging or reacting. We're harmonizing.
I wonder if, well, are you coming on Wednesday when we do Buddhism? Because the Buddhism, yeah, that's going to be, it sounds like you're going to have a lot to talk, a lot to say that day.
I'd love to. Yeah, I was blessed with 28 different religious philosophies in dialogue before I left high school. It was wonderful growing up. And Bohm was one of my mentors. as well as Gregory Bateson, which is kind of why I went into cybernetics. But I just love this group already. This has got my kind of people. I love talking about any of this stuff.
All right, well, there's 4 more days, and so on.
Thank you for doing this.